Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. In this hour, we're going to do something different. Instead of taking listener phone calls, I'm going to go through some of the emails that I get. And so once again, I apologize. I can't possibly respond to all the emails that come pouring in. However, I've grouped them in several categories. And so we'll talk, for example, about the volcanic eruption in Hawaii. Is that a sign of a major supervolcano eruption in the future? Also, parallel universes. Quite a bit of astronomical articles are now being written, serious articles, about what it would be like if there really are other parallel universes. And speaking about outer space, the United States recently launched the test satellite, which will be able to figure out thousands of Earth-like planets and Jupiter-sized planets in outer space, a replacement for the crippled Kepler satellite. And what about robots? Robots are getting increased attention, especially because robots are now entering our cars in the form of driverless cars. But what does it mean if robots one day become self-aware? Or even before that, what about our jobs? So I'll say a few things about what jobs I think are going to flourish in the future and which jobs are, well, let's be frank about it, dead ends, because they're going to go the way of the blacksmith and the way of the wagon maker. And then we'll say a few things about, well, is it possible to extend the human lifespan? I've gotten quite a bit of emails about people wondering at what point might we become immortal? Maybe digitally immortal, maybe biologically immortal. Well, these are just a fraction of the questions I get on email, and we're going to address them in this hour of Science Fantastic. Well, first of all, the Hawaiian volcanic eruption in Kilauea. That's grabbed the headlines, but the question is, can it get worse? And the answer is, well, in principle, it could get much worse if you have what is called a supervolcano. Supervolcanoes, for example, we think almost destroy humanity 75,000 years ago. That's how dangerous they are. And we have one supervolcano lurking, not under Hawaii, but under Yellowstone. That's right, Yogi Bear is not the only inhabitant of Yellowstone National Park. Right underneath Old Faithful, we have a gigantic supervolcano that, if it were to erupt, would literally destroy the United States of America. It would literally tear the guts out of the American Midwest and do what it did several times in the past. That is, cover huge parts of central United States with a blanket of toxic dust, sulfuric compounds, and horrible poisons. Now, it turns out that, yes, 75,000 years ago, we think that humanity was almost pushed to the brink of extinction. That's right, we almost went the way of the dinosaurs 75,000 years ago. There was a volcano called Toba in Indonesia. It had the biggest eruption in perhaps the last billion years. It covered huge parts of Indonesia, India, and Africa with layer upon layer of soot. Enormous quantities of vegetation and wildlife died as a consequence. And we think, believe it or not, we think that only a handful of humans survived that cataclysm. How many? Perhaps no more than 1,000. I mean, think about that. This is mind-boggling. 1,000 people left Africa 75,000 years ago to repopulate the entire surface of the planet Earth. This is absolutely staggering in its implication. And what's the proof? The proof is in your blood. That's right. If you analyze your blood and you detect your genome, you find something rather curious. First of all, if I take any two animals, like two dogs, two cats, analyze their blood, we find that they are separated by quite a bit of genetic distance. However, when you take two humans and analyze their DNA, you find something rather staggering, and that is we're almost twins of each other. That's right. Compared to the animals, we are all twins. Now, this may seem impossible because, of course, humans come in all sizes and shapes, right? Well, wrong. It turns out that any two animals are much farther apart genetically than any two humans. Now, what does that mean? That means that at one point in the distant past, there was a common ancestor that gave birth to the entire human race. How many? Using mathematics and computers, you can actually calculate a few hundred to perhaps 1,000 individuals gave rise to the entire human race. This is amazing. This means that about 200,000 years ago, we had an ancestral Adam and Eve. Now, again, we're not talking about a single Adam or a single Eve, but a collection of them, a tribe that contained different Adams and Eves that then proliferated to give you all of humanity. In fact, we even have maps, genetic maps of how it happened. We left Africa, a few hundred, maybe 1,000 of us, went into the Middle East. From the Middle East, we then spread into parts of Russia, and then we doubled back from Russia into Northern Europe, and then into Asia. Well, moving on, we were talking about supervolcanoes much bigger than the current eruption taking place at Kilauea in the Big Island of Hawaii. There are, in fact, supervolcanoes that in the past almost wiped out the entire human race, leaving only a few hundred of us, maybe 1,000 of us left to repopulate the entire planet. And if you go to National Geographic website, you can actually see many of the trails that we took emanating from Africa. Not one, but several different migrations left Africa, went into Asia. About 3 different migrations went into the Americas, for example, and they are the Native Americans. And so we can now trace back in history all the different migratory patterns of our ancestors. The Polynesians, for example, many of them came from Taiwan. That's right. People from Taiwan, many of them left there, and they were able to navigate and eventually colonize many of the Polynesian islands. And the Gypsies, for example, were a big mystery for thousands of years, but we now know that Gypsies are basically from India. A group of people from India left India, went toward Europe, and became the Gypsies of today. And so many of the genetic mysteries of the human race are gradually being teased apart as we sequence the DNA of, well, everybody on the planet Earth. And going back to Hawaii, the danger of a volcanic eruption in Hawaii is something that you may not think about, and that is a steam explosion. Believe it or not, steam explosions can release a catastrophic amount of energy, enough to blow an entire island off the map. It turns out that in the Kilauea, Hawaiian volcano, there's a large mass of liquid lava and magma, and it sits right on top of the ground table where there's plenty of water. If that magma comes in contact with the groundwater, then all hell could break loose. You can get a steam explosion which will blow gigantic boulders way up into the sky, causing death and destruction on the Big Island of Hawaii. Now, you may say to yourself, well, gee, steam explosions, we don't have that much experience with steam explosions. Well, actually, that's not true. It turns out that many of our nuclear power plants have blown up because of steam explosions. There you have hot molten uranium fuel in a meltdown coming in contact with cooling water, causing a steam explosion. The biggest steam explosion of modern times took place in Chernobyl in 1986. Yes, it turns out that reactor outside Kiev in the Ukraine had a melting incident. It turns out that some of the control rods in the core did not function properly. A chain reaction happened. The reactor went supercritical, in some sense, a small atomic bomb. And as temperatures rose, it came in contact with cooling water. And when hot molten metal comes in contact with cold cooling water, you get A steam explosion. That steam explosion blew the lid right off Chernobyl, creating this gigantic meltdown and catastrophe that is still, even today, ranks as the #1 nuclear accident. And so steam explosions are nothing to laugh at. The Chernobyl accident of 1986 is an example of the enormous energy packed in a steam explosion. Now, we've actually had them in the United States as well, but they've been covered up. In 1961, in Idaho Falls, Idaho, the SL-1 nuclear power station was operated by the United States Navy. It was a military reactor, and it had one main central control rod. That central control rod controlled the chain reaction so that it would not go supercritical and it would not erupt into a small atomic bomb. Well, right after New Year's in 1961, for reasons we still do not understand, one of the workers apparently got drunk, we're not sure. He went on top of the reactor and he manually pulled out central control rod number 9. You're not supposed to do that. You're not supposed to remove the brakes of a speeding car, and you're not supposed to remove the central control rod of a nuclear power plant. Well, what happened after that was catastrophic. After removing the control rod, the chain reaction went supercritical, and in fact, it was a small atomic bomb. Water vaporized immediately upon hitting the molten metal and caused a steam explosion. The steam explosion blew the rod vertically up, impaling the operator right in the groin, and then pinned him on the ceiling of the reactor. Poor guy. He died impaled on the ceiling of a nuclear power plant as radiation spread throughout the reactor. Well, as you can imagine, all the alarms went off. When workers finally went there, they found that the radioactivity in the area was lethal. They couldn't get close to Mr. John Burns, who was impaled on the ceiling of the reactor with a control rod right through his groin, impaling him on the ceiling. Well, believe it or not, the military actually has motion pictures of the decommissioning operation. In order to get access to Mr. Burns and get access to the reactor, they had to cut the side of the reactor off using a saw, and then insert a crane horizontally, and then yank the central control rod, releasing Mr. Burns from the top of the reactor. Well, yes, sometimes people say that no one's ever died in a nuclear power accident. Well, that's not correct at all. Back in 1961, Mr. John Burns was impaled when a small atomic bomb went off right under his feet at the SL-1 nuclear power station outside Idaho Falls, Idaho. So the point I'm raising is steam explosions are extremely dangerous. And that's what could happen if the Kilauean volcano goes out of control. This has to be looked at very carefully over the next period of time. Well, moving on, another question I get in my emails concerns parallel universes. That's right, parallel universes have been getting quite a bit of play recently on TV and the media because, well, believe it or not, we physicists are taking it very seriously. Now, you may say to yourself, come on now, give me a break. I mean, physicists taking science fiction ideas and working out the physics of these things? I mean, what's the proof? Well, there are indirect and possibly direct ways to show, prove or disprove the existence of parallel universes. For example, the strongest argument for parallel universes is what's called the fine-tuning principle. Now, let me explain. When I was in second grade, something happened which really changed my attitude towards science. My second grade teacher, I still remember, walked in the room and one day announced that God so loved the earth that he put the earth just right from the sun. Not too close, because then the oceans would boil. Not too far, because the oceans would freeze. But God put the earth just right from the sun, and here we are today, because God so loved the earth. Well, I was impressed. It kind of like shook me, realizing here was an argument about the universe that we could actually talk and eventually experiment with. Yes, the earth is just right from the sun. If it were too close, the oceans would boil, yes. If the Earth were farther away from the sun, yes, the oceans would freeze. But we are just right from the sun. Now, what does that mean? Well, you may also realize that science has moved forward since when I was a child. Now we have discovered 4,000 planets orbiting other stars. And for the most part, most of them are too close. Most of them are too far away. If they had oceans, they would either be steam or solid ice. So in other words, there's another way of looking at the question. God may or may not exist. Who am I to say? However, there is another explanation for the fact that we are just right from the sun. And that is, there are thousands of dead planets out there. Thousands of planets that simply do not have life on them. Science Fantastic with Professor Michio Kaku. In this hour, we're not going to answer listener phone calls because I get a pile of emails that have been building up. And so I have to answer some of these emails or else you're going to get angry at me. And one question that I often get is about parallel universes. Why do we physicists believe in them? Well, first of all, as I mentioned, there's the statistical argument that our Earth does seem to be special, that we are just right from the sun, not too close, not too far. So either the Earth is just right from the sun by design, so someone designed the Earth to be just right, or there are a lot of dead Earths out there, that it's a crapshoot, that randomly we happen to be on an Earth where this Earth is just right from the sun. Otherwise, we wouldn't be here to talk about it to begin with. So we are winners of a lottery, basically, that there are thousands of planets out there that are unsuitable for life. Now, here's another argument. The fundamental constants of the universe are tuned just right to allow for intelligent life in the universe. For example, if the nuclear force were stronger, that means the sun would have burnt out billions of years ago, and there wouldn't be life on the Earth because the sun would have exhausted its nuclear fuel. Now, if you change the constants of the universe a little bit so that the nuclear force is weaker, it means that the sun would never have ignited to begin with, and we still wouldn't be here. It would be dark. It would be cold with no sun. So the nuclear force is tuned just right to allow for humans to exist, or gravity. If gravity were a little bit stronger, then we would have had a big expansion, a big bang, and then a big crunch. The universe would have disappeared in a big crunch billions of years ago. If gravity were weaker, the universe would have exploded and just kept on going and never stopped, and we'd all be frozen right now. But here we are enjoying a universe with a sun that is just right to warm our bodies, and a universe that is just right so we don't freeze to death or we're not crushed by the big crunch. So in other words, the fundamental constants of the universe are also tuned just right. Now here's the killer now. Here's the killer. If the Earth were a byproduct of an accident, so that's we are just right from the sun, maybe our universe is also a byproduct of an accident which makes possible life in this universe. In other words, there are probably billions of dead universes out there. Universes where there are no stars. Universes where the stars burnt out. Universes which had a big bang and a big crunch and have vanished into existence. Maybe there are billions of dead universes out there, and we're the only ones that have living beings in them, and we're here to talk about it. Otherwise, we wouldn't be here to talk about it to begin with. So these are the philosophical arguments for parallel universes. And then we have the physics arguments for parallel universes and the possibility of measuring them. You know, we can now measure gravity waves in outer space. The Nobel Prize last year was given to 3 astronomers, physicists, who were able to detect gravity waves emitting from colliding black holes in space. The next generation of gravity wave detectors could be satellites orbiting the sun and so sensitive that they can pick up gravity waves from the instant of creation itself. The shock wave. The shock wave of the Big Bang was so great that echoes from that shock wave are still with us today. This means that we may be able to pick up radiation from the instant of the Big Bang itself. That's amazing. This means we might even get baby pictures. Baby pictures from the instant of creation, when the universe was only a trillionth of a second old. This is well within the realm of possibility now. And if we now run the videotape backwards, we may even be able to guess the radiation before the Big Bang. Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, once again, we're answering some of the piles of emails that I get. When we last left off, we were talking about parallel universes. And yes, one day we will send gravity wave detectors into outer space and get baby pictures of the instant of creation. And then we're going to run the videotape backwards and get radiation from before the Big Bang. And that may give us a clue as to where the universe actually came from. Some physicists are betting that we'll detect an umbilical cord of the infant universe as it was weaned away from its parent universe. In other words, a parallel universe giving birth to a baby universe. A baby universe, by the way, is a term that Stephen Hawking used to describe the fact that universes can literally give birth to baby universes. And maybe that's where it all came from. Well, moving on, I get a lot of emails about robots, especially people concerned about their jobs, and people concerned about, well, one day will the robots take over? First of all, let's say a few things about the job market. There's a lot of hysteria in the media about what robots can and cannot do, so let's be very clear about this. Robots at this point are basically adding machines. They add millions of times faster than us, giving us the illusion that they are thinking, but they're not creative. They're not spontaneous. They can't crack a joke. They can't write a novel. There are many things that robots cannot do. However, what robots can do is incredible. They can be search engines. They can go through mountains of data. They can do repetitive tasks over and over again. So you can now make a list of the jobs that will flourish and the jobs that will be destroyed by robots in the future. First of all, the big loser. The big loser in all of this is people who do repetitive work. Anything that is repetitive and is worth automating will, in fact, be automated in the future. This means that factory work will gradually be phased out. This also means that search engine work will be phased out. For example, in a law firm, we have paralegals. Paralegals spend a lot of their time looking at previous court cases, precedents of the past. Well, that's what robots can do. Robots can be search engines, and they can be search engines much faster than humans. But lawyers will have jobs in the future, because who's going to argue to the jury? Who's going to argue to the judge? Only humans can argue with other humans. Humans understand social standards, social mores, the change of ethics as time goes by. Robots are clueless because robots are adding machines. Now, stockbrokers, you may think, will be the first ones to be automated because, well, you can buy stock on your wristwatch. In the future, you simply talk to your wristwatch and buy whatever stock you want. So why go to a stockbroker? Because you want something that robots cannot provide, and that's the key. That is intellectual capital. That means knowledge, experience, know-how, savvy, creativity, leadership, of which robots are clueless. So those are the jobs of the future, not the repetitive jobs, but two kinds of jobs will flourish in the future. First is intellectual jobs that involve thinking, like artwork, like acting, things that robots cannot do. Those jobs are going to flourish in the future. Also, jobs that involve semi-skilled work that's non-repetitive. Garbage men, for example. Sanitation workers will have jobs because every garbage is different. Robots cannot pick up garbage, believe it or not. Robots cannot fix your toilet. Think of all the toilets of the future that are going to be broken. No robot on Earth can fix a broken toilet. This means gardeners will have jobs, police will have jobs, construction workers will have jobs, carpenters will have jobs. So, well, let's take a short commercial break, and then we'll try to answer the question, are they dangerous? Will they take over? Science Fantastic with Professor Michio Kaku. Before the break, we were talking about what kinds of jobs will flourish and which kinds of jobs will be obliterated by the computer revolution. Basically, the jobs of the future will be jobs that robots cannot do. And jobs that robots cannot do fall in certain categories. First is interacting with humans. That's why lawyers will have jobs in the future, because that involves understanding the thinking process of people. Policemen will have jobs because that requires understanding the thinking process of criminals. And so jobs that involve close human interactions will survive in the future. Counselors, for example, mentors, professors are going to be more and more into mentoring rather than regurgitating things that you can see on a videotape. And jobs that involve common sense. Robots don't have common sense. They don't know, for example, that water is wet. Why can't water be dry? Well, robots don't know. They haven't seen or touched water, so they don't know. And jobs that involve pattern recognition. That's where, well, robots are getting smarter at this, but still they cannot recognize the human face at all angles. They can recognize the human face only at a certain angle, but if you rotate the human face, robots cannot understand or cannot identify who that person is. And so jobs that are semi-repetitive, semi-skilled will be flourishing in the future, like gardeners, like construction workers, like plumbers, carpenters. These jobs are non-repetitive. And the biggest category of winners is intellectual capitalists. That includes artists, novelists, comedians, actors, atomic physicists, things that involve thinking. Jobs that involve creative thinking are going to be the jobs of the future. So what do we do about it? Get educated. What you can do is get educated, because computers are not going backwards. We're not going to go back to the Dark Ages. We have to get used to the fact that a higher level of education will be required. And then I get another set of questions. Are the robots dangerous? Well, we've all seen The Terminator with Arnold Schwarzenegger, but Hollywood makes money scaring the pants off us, independent of reality. They don't care about the reality of the situation. Robots today have the intelligence of a cockroach. If you take a cockroach and put a cockroach in a forest, the cockroach immediately finds food, mates, and shelter. Very good at that. If you take a robot and put a robot in the middle of a forest, what does it do? It gets lost. And so we have a long ways to go before the robots become self-aware. And that's the tipping point. Robots today do not know they are robots. They're adding machines. Adding machines do not know they're adding machines, even though they can add much faster than us. And the same thing with robots. However, it is only a matter of time before they do get self-awareness. At that point, which I suspect is perhaps late in this century, who knows for sure, but at that point, they could be dangerous. At that point, I think we should put a chip in their brain to shut them off if they have murderous thoughts. So, are they dangerous? Well, not for many a decade. However, it's good to think about it, because one day it could happen, and we certainly don't want to be caught with our pants down once the robots become intelligent. And also moving on, we have another set of questions about the human lifespan. You know, back in the days of the Roman Empire, people didn't live very long. You were lucky if your life expectancy was about 30 years of age during the Roman Empire. And when the Roman Empire fell apart, life expectancy dropped to about 25 or so. Now life expectancy is rising past 70, approaching 80, and we wonder, how far can it go? Well, we don't know for sure, but we think genetics has a lot to do with it, because if I take an animal, I can find that they have programmed within it a different lifespan. Mice, for example, live on average of roughly 2 years, but the Greenland shark can live 500 years. Amazing. The longest lived vertebrate is the Greenland shark. And how do we know how old it can live? Well, we take the eyeball of the Greenland shark, and we find that the eyeball consists of many layers, like tree rings. And by counting tree rings and counting these layers, we can calculate the age of a tree, and we can also calculate the age of a Greenland shark. And yes, many of them are between 400 and 500 years of age. This is astounding. What it means is that genetically speaking, we might also be able to live hundreds of years, but how do you do it? Well, of course, no one knows, but we have some ideas. One is to reset the biological clock. I once interviewed Professor Hayflick, who discovered the Hayflick limit. He discovered that if you take skin cells and look at them under a microscope, they divide about 60 times, get old, senescence, and then die. In other words, there's a clock. The clock ticks away, and after 60 reproductions, the cell says, time to sleep and time to die. In fact, that's one of the reasons why we die. We are programmed to die in some sense, but if you hit it with an enzyme called telomerase, it lives forever. I mean, think about that for a moment. Your skin cells can be made immortal so that they will keep on dividing thousands of years into the future. Now, we can't do it, of course, but with telomerase, it is possible to immortalize a human skin cell. So what's the catch? The catch is that cancer cells also use telomerase to live forever. Now, why are cancer cells dangerous? Cancer cells are dangerous because they don't die. They live forever. They are immortal. They keep on dividing until they form a tumor, and that kills you. So one day, if we can reset the clock, who knows, we might be able to live forever. Well, unfortunately, that's it for Science Fantastic.